In the spring of 2018, a survey of an unfinished skyscraper in Lower Manhattan revealed something alarming. The tower wasn't standing straight. It was leaning about 3 inches to the north. And it was only halfway to its final height, but construction didn't stop. Instead, as crews poured the floors above, they began adjusting the structure in the opposite direction, trying to compensate for a problem already built into the tower 30 stories below. The building is 161 Maiden Lane, also known as One Seaport. It rises roughly 670 feet beside the East River in Manhattan's financial district. And once the lean was discovered, the people building it faced an extraordinary problem. How do you straighten a skyscraper that's already halfway built? Their answer was to keep going. The idea sounds strange, but the logic was fairly simple. If the lower part of the tower had drifted north, later floors could be adjusted slightly south. In theory, the upper structure could compensate for what had already happened below. But that didn't make the original deviation disappear. Instead of one perfectly straight tower, different sections were now being built with different alignments. The lower portion leaned one way. Higher floors were adjusted back the other way. And eventually, some floors were reported to be many inches away from where the original plans expected them to be. When the dispute later reached court, one lawyer used a much simpler description. The tower had become banana-shaped, not because engineers had designed a curved skyscraper, but because they were trying to correct one alignment problem while the building was still rising. And that raises the obvious question. How does a brand new Manhattan skyscraper end up like this in the first place? Part of the answer may lie beneath the building. 161 Maiden Lane sits on the edge of Lower Manhattan, on land that didn't exist in its current form centuries ago. Much of this shoreline was created by extending Manhattan into the East River with fill. Beneath the site are layers of fill, softer soils, and other material before reaching much stronger ground far below. That's a serious consideration for any building. For a tall, narrow skyscraper, it matters even more. One conventional solution is to carry the building's loads deep into stronger material using piles. But 161 Maiden Lane used a different foundation strategy. The project relied on ground improvement, strengthening the soil beneath the building, combined with a large concrete foundation mat. The approach avoided the need for piles extending all the way to bedrock and was reported to reduce costs by several $1 million. But whether that foundation decision caused the tower's later problems would become one of the biggest arguments surrounding the entire project. Because before construction was finished, something below, or something in the way the tower was being built above it, had allowed the structure to move out of alignment. Construction began in 2015. For the first few years, the tower rose much like any other high-rise in Lower Manhattan. Concrete floor followed concrete floor. Then came the measurements. By April 2018, with the structure already more than 30 stories high, surveys showed that the tower was measurably out of alignment. One reported deviation was roughly 3 inches toward the north. Other measurements found additional differences between sections of the structure. 3 inches may not sound like much, but skyscrapers are built around extremely tight tolerances. Floors, elevator shafts, facade connections, mechanical systems, and thousands of other components all depend on the concrete structure being where engineers expect it to be. And this tower still had dozens of floors left to build. The problem was now obvious. What wasn't obvious was why it had happened. And instead of waiting for that argument to be settled, construction continued. By September 2018, 161 Maiden Lane had topped out, but by then, The disagreement over the lien had become a legal battle. Pizzarati, the general contractor, argued that the foundation strategy had allowed uneven settlement beneath the building. According to that side of the dispute, the problem began below ground. Fortis Property Group, the developer, disagreed. It blamed problems with how parts of the concrete structure had been constructed. Fortis also brought in engineering firms whose assessments concluded that the building's alignment issue did not represent a threat to its overall structural integrity. So everyone could see the same thing. The tower was not aligned as originally intended, but the two sides could not agree on why. One side pointed toward the foundation and ground below. The other pointed toward construction above it. And while that argument moved into court, engineers and contractors were left with a much more practical problem. How do you finish a skyscraper when the structure underneath everything else no longer lines up the way the plans expected? This is where a small geometric problem becomes a huge construction problem. A skyscraper isn't simply a concrete frame. It's thousands of separate systems designed to fit that frame. Take the exterior glass. Curtain wall panels are manufactured to connect to specific points on each floor. Move those points several inches, and the panels may no longer meet the structure exactly as designed. Waterproofing connections become harder. Window openings can move out of position, and elevator systems face an even more obvious challenge. An elevator needs a shaft and guide rails that remain precisely aligned over hundreds of feet. Now imagine trying to install all of that inside a tower where different sections have been adjusted in different directions. That was the unusual geometry engineers were dealing with at 161 Maiden Lane. The lower part of the building had deviated one way. Later construction had been adjusted in an attempt to compensate. So this was no longer simply a straight tower leaning slightly to one side. Different parts of the structure were now out of alignment in different ways. By 2019, measurements near the upper portion of the tower were being reported at around 8 inches out of alignment. The attempt to compensate hadn't erased the problem. It had changed the geometry of it. Eventually, the engineering dispute became a construction deadlock. In the summer of 2020, work stopped. The replacement contractor left the project amid a payment dispute. The cranes disappeared, and a nearly completed 60-story skyscraper was left standing beside the East River. Because the building was unfinished, important systems were unfinished too. Fire officials later found problems with the tower's standpipe system, which is supposed to carry firefighting water through a high-rise. Systems intended to control movement in the slender tower had also not all been completed. There were reports of problems involving sections of the facade. And instead of becoming one of Lower Manhattan's newest luxury residential towers, 161 Maiden Lane became something much stranger. A nearly complete skyscraper that nobody could use. Years passed, the lawsuits continued, but the tower stayed exactly where it was. As of 2026, 161 Maiden Lane remains unfinished. Nobody lives there. The project has accumulated open violations and has gone years without returning to normal construction. Yet there is an important distinction. New York's Department of Buildings has said it has not found evidence that the structure itself presents an imminent danger to the public. So the tower exists in an extraordinary kind of limbo. Not dangerous enough to condemn, not finished enough to occupy. And the engineering lesson is much bigger than one troubled project in Manhattan. Tall buildings depend on thousands of parts lining up within tiny tolerances. A deviation that sounds insignificant on the ground can become enormously difficult to deal with once dozens of concrete floors already exist above it. At 161 Maiden Lane, the attempt to compensate didn't simply make the original problem disappear. It created a new challenge: how to finish a skyscraper whose different sections no longer lined up exactly as originally intended. And years later, the unfinished tower is still standing beside the East River. A 670-foot reminder that in skyscraper engineering, a few inches can be very hard to get back. If you'd gotten that survey in April 2018, with the tower already leaning, 30 floors built, and roughly 30 more still to go, would you have kept building and tried to correct it? Or would you have stopped everything right there and accepted the loss? Let me know in the comments. If you enjoyed this video, don't forget to like and subscribe for more stories about engineering and the breakthrough technology shaping our future. Thanks for watching, and I'll see you in the next one.